So today we're doing experiment 6, the Kool-Aid acid test pre-lab questions. And for this experiment, what you're going to be testing for and looking at is you are going to go into lab and do an acid-base titration. And from that titration, the data you obtain, you're going to be able to determine the amount of citric acid present in a package of Kool-Aid. You're then going to be able to express that in terms of percent composition. So the pre-lab questions for today are going to look at determining the concentration of citric acid and also expressing it as a percent composition. So if you look at the problem, and in your lab manual you'll see that there is actually a diagram, figure 6.3 in your lab manual. And if you look at this, what it says is that you have tested a 0.7 gram amount of drink mix, okay, and you have dissolved it in enough water to make 100 mils of solution. So from this, you have a concentration of drink mix. Now, you do an acid-base titration in order to determine how much citric acid is present in this solution. And what you see is that while doing your titration, when you look at your experimental data points, you see that there's a place, if you look at figure 6.3, where the pH makes a very sudden jump. Okay? And if you look in your lab manual, you'll see that. The exact point of equivalence, okay, is where you have equivalent amounts of acid and base together. Now, this is what we use to determine the amount of citric acid, which we don't know, in the drink mix. So we're doing an acid-base titration. We're using a known concentration of base. We're using a known amount of base to determine the unknown amount of citric acid in drink mix. And this is exactly what you're going to do when you get to lab and perform experiment number 6. You are going to test a drink mix and determine how much citric acid is present by using a known concentration of base and determining where the equivalence point is, and using that volume you can determine the amount of citric acid, and then you can determine the percent amount of citric acid in your drink mix. So if we get started on this question, what we see is the first part of the question asks us to calculate the moles of sodium hydroxide added to reach the equivalence point. So we know at the equivalence point that we added 23.25 mils of a 0.4 molar solution of sodium hydroxide. So right now we have milliliters of this amount of sodium hydroxide, and we want to obtain the moles of just sodium hydroxide. So this is a solutions calculation. So with this particular problem, we know that when we look at it, we see, oh, I have one volume and I have one concentration. And you see these brackets here. That is an abbreviation for concentration. So when you have one volume and one concentration, generally what you need to do is you need to start with the volume, and if it's not in liters, you need to convert it to liters. So we have 23.25 milliliters, and in this instance, it is not in liters, so we need to convert it to liters. So I know that the conversion from milliliters to liters is, I have for every 1 liter, there is 1,000 milliliters. This is my conversion factor. So if I set it up so that milliliters cancels out, leaving me with liters, I have 1 liter over 1,000 mils, and if I cancel my units, I see that milliliters has now been canceled out, leaving me with my desired unit. So that's the first step, when you have one volume and one concentration. Generally, the next step is we want to multiply by the concentration of base, because what you'll see happening is right now we are in a volume unit, liters. But that's not what the question is asking us for. It is asking us for an amount, moles of sodium hydroxide. So we have to cancel out the volume units in order to be left with the moles, the amount unit that we need. So by multiplying by the concentration of our base, we have 0.40 moles of NaOH per 1 liter. And remember, when you have a concentration written out as big M, when you do calculations, you always want to write it as moles over liter, because if you don't, you won't see the units canceling themselves out. So as we go through, we see mils has canceled, liters has canceled. Right now, we have moles of NaOH left, and that is exactly what the question is asking for. So we know that we set it up appropriately. And when we do our calculation, we get an answer of 0.0093 moles of NaOH. And with this, we have to pay attention to significant figures. We see that from our volume, we have 4 significant figures. So we have 4 sig figs. From our concentration, we have 2 sig figs. And we know that since we're multiplying, we want the fewest significant figures. So we know that our final answer must have 2. And we can either write this as 0.0093 or 9.3 times 10 to the minus 3 moles of sodium hydroxide. So we did the first part, and like I mentioned, this is exactly what you're going to do when you get to experiment number 6, this type of calculations.